Okay, shall we begin?
Okay, I'm ready.
Yeah. Okay, so it's my pleasure to introduce Professor Lê Quý Thuong from Vietnam National University in Hanoi, and he will talk about the ACVF theory and motivic myelofibers. So please.
Okay, thank you very much. First of all, I would like to thank you very much for introduction and for introducing me to the seminar. The title of the talk says about the contents. This is a comparison with between ACVS theory, motivic integration in the sense of conceiving solvent, conceiving the nebulosa and that of Ruski Katans. So, and now in the talk, I will say a few words of classical motivic integration invented by Concevics and developed by the nebulosas. And then I mentioned the recent development of motivic integration by Ruski Katans in the ACVF theory. And the construction of Ruski of motivic myelofibers in terms of the ACVS theory. And the last part I mentioned some application of methods in Ruski Katans motivic integration to some problems. So first one, I say something about the motivic integration. It's developed from periodic integration. The periodic integration is of subsets of locally compact species and motivic measures. It concentrates on the formulas. It is uniform in value fields. So in motivic integration, motivic means uniform, and we do for every value fields. So now we start with the conceiving the nebulosas classical motivic integration. First of all, I mentioned the language of the repast. The language of the repast has three sorts consisting of L1, Lres, Loff, and two additional symbols off and AC bar. VF source has a language L1, L brings. The language of brings consists of some symbols plus, subtraction, addition symbols, subtraction, and multiplication symbols, and two constant is 0 and 1. And a K source for residue fields, we use an extension of the language springs, and gamma source for value fields. We use an extension of the language of orders abelian groups, and two more simple order arc and AC bar. They correspond to some function from VF to gamma and VF to K. And so in the case where the language LOX is the Pressburger language, we get the language LDPP. This is the sub-language of the Laplace language, and Kosovic, the nebulosas, uses language to build motive integration, classical one. So let me go to details on the construction of the Laplace. We start with the definition of the logarithmic rings of variety. In the theories of the Laplace, they use heavily the resolution of singularities. So the ground field case is always characteristic 0. So definition of logarithmic ring varieties, we just in this case the your fields. Let vacate the categories of algebraic varieties, and the logarithmic ring of varieties is abelian. In a group, this is abelian group generated by isomorphism classes of K varieties. Modulo the question, the condition like this: the class of X is equal to the class of Y plus the class of the complement of Y in X, where Y is actually closed subvarieties of X, and it becomes a ring with the product, the class of X times class of Y is a class of the fiber product of X and Y. Okay. And this is a commutative ring with unities. Unities is the class of space K. So we also use localization of the logarithmic ring varieties. It denoted by MK by inverting the class of apply A1. So for case fields of characteristic 0 and X varieties, they can contrast Z scheme and R spaces. And in this case, we have the functor from algebra to the category of sets. And this functors is a representable functors, and it defines a scheme, and we call it NZ scheme. And on NZ scheme makes a projective system where the math from LM to LN generated by the transcation map. So limits the R space of X, and then also by pi n the natural map from the R space to NZ scheme. A subset of Lx is called semi-algebraic if locally is given by the formulas in the Laplace Presburger. In the very special case where we consider A is a preimage of C, where C is a constructible subset of Lnx, and it's eight normally called cylinders. In this case, we define the motivic measures of A is a class of C times L to the power minus n plus 1 d, as see in the screen. So this is the first step of construction of motivic measures. And they would like to extend the mu to all semi-algebraic subsets of the R space of X, but we need to extend the the value domain, and so they takes the completion of the golden ring MK, and so in this sense, all the semi-algebraic subsets of Lx is measurable. If A is a semi-algebraic subset of arc space of X, and all the fibers of a function from A to Z are semi-algebraic, and one more condition, the sum uh, running over Z of mu's of the measures of the fiber of the fibers of alpha over n times L to the power n in the completion of mu k, then we call L to the powers minus alpha is integrable on A, and the quantities I of both. It's called the multiplic integrals of L to the power minus alpha, and then also like this. So this is very important for theories of integration, which is change of variables formula, and this one is invented by Concevis and introduced and in 1995, and he said the change of variable formulas with the proper variational morphism is from Y to X, then we can compute the multiplic integrals of L to the power minus alpha over A instead of the multiplic integrals of some functions over some semi-algebraics of the arc space of Y, which is maybe easier. And by using the theorem, Concevic can prove the conjectures by direct if X and Y are two variational equivalent smooth proper Glavial varieties, then they have the same vector numbers, and the proof very simple. And now I would like to mention the equivariant action of um, some multiplic quantities. This means I want to mention multiplic variables and monoramic quadratic rings of varieties. We consider the categories of K varieties with a good action of mu hat profinite subset profinite group scheme, which is positive limits of mu n like this, and we also consider quadratic rings of these categories with similar as the quadratic ring of varieties in the relative in the non in the non-action version. So in this case, we you can see the two conditions. The first one, we have the class of X is equal to class of Y plus the class of the complement of Y in X for every close statistically close invariant subset y in X. And the second condition, we consider all the action on affine uh, affine species action as the same. So and this one is also bring with the unity with respect to the fiber product, and we can consider the localization of this and denoted by mk mu hat. So let's get this fields of characteristics 0 and x is answer. In this slide, I should write more. It is a smooth, answering smooth varieties of dimension d, and f is a function of x on x, and we denote by x0 the zero locus of the function. For any close points of x0, we can consider the varieties x and f. It is a set of arcs in NZ is Lx. Thus, phi 0 is x, and satisfying the condition f phi t is equal to t modulo t to the power n plus 1. And we can consider the mu and action on these varieties given by psi phi t is equal to phi psi t, where psi is in mu n, and it makes the class of x and x f becomes an element of monodromic quadratic rings of varieties. So we consider the motivic zeta function of x of f at x. This is a formal power series where the the, um, the the coefficient of t to the power n is the class of x and f and l d to the minus dn, and the coefficient of t to the power n is nothing but the motivic measures of this contact loss size. It's in 1998, the Nebelzer proved that the motivic zeta function is a rational series in that sense, and since the limits of the motivic zeta function exists, and we call the opposites of the limits the motivic minor fibers of f at x. And then, this one is very important in the nowadays singularity theories, because it is considered as the motivic incarnation of classical neuron fibers. So now I tend to Rupsky-Kadam's motivic integration. First, we mentioned. Okay.
Can I see the previous page? So one more page, previous page. Yeah. Oh, can I see the definition of JFT? The definition of JFXT. Can I see it again?
Okay. Let me continue.
No. I'm asking you, what was the JFKXT? Can I see it again?
F.
JFXT. What does it? Can I see the previous page? Page 13. Okay.
This is slide.
Page 13. 13 again.
13. Okay. Here.
Okay. This one. Okay.
Yeah. Okay.
Thank you.
Yeah.
Okay. Thank you. Yeah.
Okay. Let me continue with the ICBF. So I mentioned the language, Basra Kunman style language, which is sometimes the same the past language, but we have some modification. VF source for value fields with language brings, and RV source we use multiplicative group language and two constant symbols, 0 and infinity, as unary predicate, not by key by key star, and we also consider the case denotes by k the unions of k star and the constant symbol 0. A binary function denotes by addition, and unary function subtraction, and binary relation. And we also use the function symbols RV to mention the relation from VF sort and RV source. And this language of Basra Pullman style language. So now we have some interpretation. Let's K1 be as a value field with the related objects R, M, K, and gamma. And for VF source, which is interpreted as the VF case is okay. Now we can consider the VF as functions and from the categories of algebraically closed value field K. And RV source is interpreted as RV of K is equal to the quotient of K star over the ideals and subgroup 1 plus M, and the both K is equal K, and the symbols RV small RV is interpreted as a map from K star to the quotient of K star of by subgroup for 1 plus M. We also view gamma as an imaginary source. Then we have gamma K is equal to K star over R star. This is nothing but the value group of the value fields. Then we obtain an exact sequence like this. Okay, now we mentioned the theories of ACBF of algebraically closed value fields in the language. We have many of axioms. First one is we state that VF 0, 1 addition, subtraction, and multiplication is an algebraically closed field. And the second statement is RV star 1 and multiplication is a divisible abelian group with some more augmented relation as this. And the third statements we state that K01 addition, subtraction, and multiplication is an algebraically closed field. And the binary symbols less or equal have the properties of reflexivity and sensitivities on RV. And so one more statement on the theory is we have the quotient of RVs over by K star is gamma augmented by infinity symbol, which is divisible of the abelian group with the top elements. And the order induced by the symbols less or equal addition in gamma augmented by infinity symbols induced by multiplication symbols in RV. We also denote by so in this case we add one more symbols van RV for the function symbols interpreted by the map from RV to gamma union with infinity. And we have one more statement. RV from VF star to RV star is surjective of groups. And RV 0 is equal to infinities. And van can be decomposed as unions, the composition of van, RV, and RV. And this is on the axioms of the theory of ICBF algebraic closed value fields. But if you want to mention the characteristics of this, you can add some sentences like this, and we have infinitely many sentences. 1 plus 1 different from 0, 1 plus 1 plus 1 different from 0, and so on. For the VF source and for the OK source. And the most important things in this series is that this theory admits quantifier elimination. And so the following comments we intend to compare the theories of Hurovsky, Kadans, and some other theories of motive integration. Hurovsky, Kadans motive integration is a major development in motives of motive integration from Concevics and the Nep-Lozère, Kluckers, and the fundamental ideas is to build morphism between various logarithmic rings associated to the theories. In the theory, we have the three source, and each source has some we try to some categories, and we mention the relation between the growth rings of those um, um, growth varieties, growth rings of the categories. Huruf kadang multiple integration is based on the file analysis of defallable success up to defallable bijection in the language of the LL, the language LRV, Sabra Kunman. So now I mentioned the defallable sets in the theories of CVF. From VF source, we consider the categories VF star of defallable sets. And we also mentioned the subcategories Von VF star with one more condition that on the morphisms are preserving volume. And we also mentioned the subcategories Von VF BDD star. The last one we require on the sets, defallable sets have to be bounded. Bounded means the image of the sets under the morphism one is bounded. Okay. Now for RV source, we have some categories RV star, Von RV star, and Von RV star BDT in the same thing. We consider the more condition, for example, volume preserving for morphisms and boundedness for objects. If we require Van RV to be finite, instead of bounded, we have subcategory rest and also Von rest. The Von rest is subcategories of Von RV BDD. For gamma source, we have categories Von gamma and Von gamma BDD with the same condition as what is the Wu. Now, when style replaced by N, we have a similar categories of objects limited by the dimension. And now we have the fact that the category C star always the direct sum of on the category C N.
Can I ask a question?
Yes.
So these categories, so are these defined once we choose a model of the language?
The model,
or
the model.
So I thought that definable sets are defined for each model of the language, or
the defallable set is defined by the formulas in the language of.
So it's a formula, not the subset of some algebraically closed valued field. So it's not a subset of such a algebraically closed valued field, but it's just a formula.
Yeah. So in fact, the defallable success in fact is not really the a subset in the a set theory, but it's some sense like functors. And
So it's a morphism is also a formula.
yeah,
The corresponding to the graph in the
yeah,
in terms of
that's
set.
right. That's right. Yeah, we
Thank you.
take the graph and we have a definable subset.
I see. Thank you.
Okay. And now can note for each category C star, we denote by K0 C star, the boundary rings of C star. And now in the theory of Turovsky cut downs, we are interested in some structure theorems. For the morphism from RV to VF, we have integral morphisms, which is the ring morphism, the ring morphisms from the logarithmic rings of Von VF to the logarithmic ring of Von RV by some certain ideals. We can describe very explicitly the idea I, but I don't mention it in this talk. So the exact sequence mentions both K star, RV, and gamma implies a morphism of rings phi from the tensor product of the quadratic rings von gamma and von rest to the quadratic rings of the category von RV BDD. And so from two ring morphisms, you can think about the relation between on the categories, the quadratic ring of categories correspond to VF source, RV source, and gamma source. It's a nice one. And so based on the two morphisms, Hurovsky and Lozère contrast some more ring morphism to in order to describe the motivic neuron fibers in terms of some definable subsets in the Hurovsky-Cartan model integration. And now I mentioned this one. In this case, we let K be an algebraic closed field of characteristic 0, and big K is the algebraic closures of KT like this, and this one is the localization of this logarithmic ring of the category von Rest with respect to this. We have to then need some constant things, and we use this one, these symbols. So and now the ideas is we the ideas of Hurovsky-Lozère. You want to construct the morphism from this one to go to the ring of varieties, and this is also morphism from this one to go to the ring of varieties, and take this and this, we have a morphism from this one to the quadratic ring of varieties. Here, by construction, AN is a ring morphism from the Gothic ring of Von gamma BDD to this. It is constructed as follows, which is very explicit. So in fact, we can think of the morphism one, and we take the pre-image of one, and which is the pre-image of one is a definable subset of in VF sort, and so we take the class of it have this one, something like this, and the second ring morphism from the Gothic ring of von Rest to this, it is defined very simple. And now we take the tensor product of AN and BN, and we obtain ring morphisms from the Gothic rings of von RV to this, which is factorized through the question. This you remember this question because it's concerned to the Gothic ring of von VF. Let me back some here. This one, this is a question. We have the relation with the Gothic ring of von VF here. And now we also divide 8 as the ring morphisms similarly as SN, with A and BN replaced by AB like this. It's very simple. A is defined by the characteristic in the sense of Hurowski-Kadam, and B is this one. And to have a morphism to Gothic ring of varieties, we consider the natural morphism. This is very obvious. So we take the composition of the integral morphisms and Sn and the natural morphisms. We get SLN and SL, and which are the ring morphism from the Gothic ring of the category von VF BDD to the Gothic ring of varieties. And this is the world of classical motive integration in the sense of conceiving the Nepal-Zen, and this one is the world of motivic integration in the sense of Hurowski-Kadam, and we have a very strong tool to describe motivic neural fibers, the classical motivic neural fibers. There were some definable subsets in VF source. And so we mentioned some very special definable subsets in VF source. The set X definable subsets of VF to the power D is said to be beta invariant if for every AX in X with the orders of XT of order T of XI greater or equal to B for one I, both A and A plus X are simultaneously in isers X or in the and its complement in VFD. So by Hurowski logic, they can compute uh, we have they can compute the image of X under SLN and especially they can prove the series SL the formal power series is irrational without using the resonance singularities. The method is very special. They cannot use the resolution of singularities. Just use some argument in moral theory. They can prove this one rational, and with and so it has a limit minus SLX. And this kind of definable subset is very special, and it is correspond to the cylinders, the stable cylinders in the center of the nebula. So and now they can recover multiple mineral fiber. Let F be the non-constant regular functions on the smooth K variety X, and small x is the close points of the zero locus of F. We can consider the xfx and xfy, where here y is the sub varieties of zero locus of F, and both xfx and both xfy become two definable subsets of VF VF to sorry definable subset in the categories Von VF BDD, and Hurowski logic can compute and obtain the motivic mineral fibers is what to the image under SL of this of bow XFX, and if we take the the um, the push forward morphisms, we get this, and this formula is very important because the left hand side is the and the motivic objects in conceiving the nebula motivic integration, and the right hand side it is the objects in Hurowski cut-down motivic integration, and this one is very flexible, and we can easily decompose it as a union or product, and everything is better than the words of classical motivic integration. And now I mentioned the integral over gamma, and we consider functions of this type from the definable subsets of gamma to the quotient ring varieties, and it is said to be definable or integrable if we can decompose D as a finite disjoint unions of Di with Di definable subset of gamma. So and the restriction of the function is constant for Si. This one, and in that case we can define integrals of gamma over D, and this is its values lives in the considering the varieties. As a definition, cost is Hurovsky-Cardon's order characteristic. Now, in the following, I mention some application of Hurovsky-Cardon motivated integration. Mainly use the methods of Hurovsky-Lozer, especially in the morphism SL and SLN. First, proof of the integral identity features for regular functions. In 2008, Cosby Sobenmart introduced the theories of Donaldson-Thomas, motivic Donaldson-Thomas invariants, and the theories depend heavily on the conjectures. It's called the integral identity conjectures. And so in this talk, I just mentioned the regular version. Regular mean we consider f is the polynomials, and which is satisfied to conditions. Vanishes at the origin, and this is f lambda x lambda inverse y is this equal to f is y is for every lambda invertible in k, and we take f prime as a restriction of f over on the third factors. Then the conjecture states that we have the identity, and the left hand side is the push forwards of this, and the right hand side is the products of L to the power D1. D1 is the numbers of x variables, and this one is the motivic neural fibers of F prime at the origin, and and in 2015 I proved the conjectures for the regular case and for the condition case. The ground field case is algebraically closed field. And now let's be this is scatter proof. Now we consider this one, and we want to take the L8, the Hurovsky-Lozer morphism to this to get the left hand side of the identity, integral identity. And if you decompose this as the disjoint unions of this one and this two, this zero and this one, and with respect to the condition, this one is the minimals of 1 xi for I running from 1 to z1, something like this. And we get the image of this one under SL is the right hand side of the integral identity. So the conjectures now is equivalent to this. The image of this one under SL have to be 0. And you take a look at the definition of this one. And we let this one lambda be the fibers over lambda of the map. We take the map, please. remember that 1x plus 1y is not equal to infinity. So we can prove that this one, the function on this gamma positives is differable by using you use the ring morphism this one, which is induced from the intermorphism and phi. And because this function is differable, and we can take the integrals of gamma positive, and this is nothing but the SL of this one. And now we have to prove this one values, and it's enough to prove the function is a zero constant function. And now we consider the action on this set. Is it defined by this condition coming from the assumption of the conjectures, this one. So we use this to make the free action of VF star on V here, and by some argument we get the identities in the golden degrees of Thuong VF, and this we have this one equal to this one, where A lambda is nothing but the annulus and the open close annulus, and it's very easy to compute that the SLs of A lambda is 0. And because we also use the fact that SL is a ring morphism, then this function becomes a zero constant function, and back here, and we get this one vanish, and finish the proof of the integral identity conjecture. And now the second application is a new proof of motivic Thuong theorem. The classical versions of this theorems mention the monodromies of the singularities of the forms fx plus zy, where x and y are separated variables, and we have the relation between the homologies of the minor fibers of Thuong type function, and the homologies of minor fibers of F and G, and this isomorphism is compatible with the monodromies of this one and this one and this one. And as this the statement of motivic Thuong theorem. In this case, we can consider any fields of characteristics 0, not necessarily isolated singularities, and we also have a motivic version of the Thuong theorems. The motivic minor fibers of F plus G plus 0 is equal to this one, and the motivic minor fibers of F at 0 and motivic minor fibers of G at 0. Here is a motivic convolution, but the definition is quite complicated. So in this talk, I just mentioned formally this one. Take convolution product with this one is equal to this. This something measure the distance of the values of this and the non vanishing of this. For example, the mu3 class of mu3 convolution product with class of mu2 is this. It. So sketch my proof using the ACVF theory, ACVF 00 theory. I typed some mistake here. It is a definition. By definition, M is the set of T in VF such that the values of tau strictly positive. And then we have this. This should be the thing in the left hand side of the identities of this. So we decompose this as a disjoint unions of x, y, and this star with respect to the condition. This one, and this one. And we compute easily SL of the class of this is the left hand side of the identities. And this one, SLX and SLY are equal to as the motivating universe of F and that's of G respectively. So you want to compute that the SL of this star equal to the convolution of this quantity. Now we decompose this star as a disjoint union, this star 1 and this star less than 1 with respect to the condition, because the valuation of fx is less or equal to 1. Here you can take this one equal to RVT. RVT means the value of t is 1. The van of t is 1. So van f is equal to this one or less. Then we have to introduce a new set. This the fellow subset. This one. It look true. So you get we have a new decomposition of this star like the sum. This one star minus z 0 is a new set, plus this one plus this this star less than 1 plus this 0, and this one. Now we can take SL, this takes the image of this under SL. It's nothing but the convolution product of multiple universe of F and G. And now we have to prove that the SL of this one is 0. And I need 2 minutes. Sorry for I'll take more time. So we consider the composition from this to this using the valuation map, and this one is very clear. So we can compute this function. This function is infallible on and this intervals, and this one is also diffusibles on the infinity intervals open. And it's easy to compute the integral, and we have this one and this one. And by construction of Rosky-Lozer, we can compute this one, these integrals like the Euler characteristic of the intervals 0, 1, and this, and the second is the Euler characteristic of this and this, and that's the fact that the Euler characteristic of this one and this one is it have a same value but opposite, and this and this one are same, so we get this one, and this equalities mean that the image under SLs of these facts of this subset of these quantities is 0. Now, recent development of tissue gene, they want to use the ACVF theory Rosky-Katang to generalize the formula of group Gibello-Zermelo. The formula to Gibello-Zermelo is to compute the motivic nearby cycles of this type of function f plus g to the power n, where n is large enough. And Fishu and Yin want to consider the singularities, and not a function, just the local singularities of the form. This one, and f to the power n, and the sum of g to the power n plus the sum of f to the power m cube. With more condition on the powers. That's the experience. So they use the construction of convolution of using ACVF theory and the comparison of ACVF and Hurowski-Katang motive integration and that of Kosevic, the Nevrozea one, and prove the formula. This is much more complicated. But if you take L is true and M true is 1, we can recover the formulas of Gibello-Zermelo. The papers of Fishu and Jin will appear in GEMS, and it's a very long paper. It's very, very difficult to read. So I'll stop here.
Okay, thank you
very much. Yeah.
Is there any questions or comments? Okay. Any comments? So if not, we thank the speaker and we also thank the organizer for a nice meeting.
Okay, thank you.
See you in 2 weeks.
Yeah, see you.